In this presentation, we will focus on how government subsidies are causing overfishing. First, we will introduce why they are highly connected. Next, we will provide supporting theories to prove our point of view. Last, we will provide three different aspects of solutions, each of them being explained with an economic approach. By the end of 2017, 34.2% of fishing stocks were unsustainable, tripled from 10% in 1972. According to UNCTAD, $35 billion are put into subsidies in fishing annually, and over 20 billion of them directly contribute to overfishing. Overfishing is a severe and rapidly worsening issue, and government subsidies have to pay major responsibility. Here is why. Subsidies were launched by governments for economic benefits, which then fell into large fleets who can make the most of it. In order to balance the high cost, large fleets chose to spend the money on technological equipment, helping them to fish in the most efficient way, which then causes massive unsustainable fishing activities, fueling unfair competition between commercial and traditional fishing.
Here's a golden shaver model. According to this model, without any restrictions, our fishing quantity will meet the bioeconomic equilibrium. However, that amount will exceed the biologically sustainable limit. Next, we're going to introduce the fisherman's dilemma brought by Colin Clark in 1985. Both firms A and B will choose not to do conservation in consideration of their own profit. But if both of them do conservation, it will actually bring the most profit to the market. With both models, we can see that without the government interfering, the market will be led to an unsustainable result. This clear connection between fiscal policy and sustainability forms the basis of our first two solutions. Our first two solutions will be based on the simple economic model we built, in which we separate the total fish supply into unsustainable fishing and sustainable fishing, seeing them as complementary products. Under this model, we made the following assumptions. First, there won't be structural unemployment and GDP loss due to the changes in the market. Second, taxes cannot be passed through. Third, the externality cost of unsustainable fishing is larger than sustainable fishing. 4. The marginal cost and average total cost are the same in both sustainable and unsustainable fishing. 5. Both sustainable and unsustainable fishing face the same demand curve. Our first solution is to cut down subsidies on unsustainable fishing. This will shift their supply curve left, forcing them to reduce the quantity of fishing. At the same time, raise the subsidy of sustainable fishing. This will lower the cost of their fishing activities, shifting their supply curve right, therefore increase their competition and encourage fishermen to change their fishing methods into sustainable ways. This shows the profit distribution after transferring the subsidies. Under this model, it successfully transfers part of the quantity used to be unsustainable fishing into sustainable fishing, while the total supply of fish remains the same. Another approach is to add taxes on unsustainable fishing. Here we separate it into unit tax and lump sum tax. If the government imposes unit tax, the short-term price will rise and the quantity will fall. Some firms will leave the market due to such profit loss. In the long term, the price will bounce back and the quantity continues to fall, which effectively lowers the total quantity. On the other hand, if a lump sum tax is imposed, the short-term price will remain the same and the average total cost of firms will increase. In the long term, the balance price will increase and the quantity will fall, also reaching the result we want. As the third approach, we analyze it with the second best theory. At present, the market does not consider the externality of fishing, so there are existing distortions and cannot reach the Pareto efficiency point. Therefore, other measures should be undertaken to reduce deadweight losses. We will use graphs to indicate the outcome. The black chart will indicate the distribution of benefits when the market does not consider other factors. The blue chart will represent the distribution considering externalities. The red chart will represent the distribution without considering externalities but after implementing the plan, and the purple chart will represent the distribution of both the implementation of the plan and externalities considered. Under the theory, we have two methods. The first one is sustainable labels. The sustainable label will indicate whether the fishing activities regarding the product are sustainable or not. As a result, although externalities still exist, it lowers the consumption of unsustainable fishing and even bring an increase in both supplier and consumer surplus. Another method is to impose taxes on rare fish. Due to its rarity, some fish have the characteristics of luxury goods. So, if a luxury tax is imposed on them, the demand curve will shift left and consumption will be reduced. Now, we add the consideration of external costs. The graphs analyze the distribution of benefits under taxation and the externalities. As the graphs indicate, as long as Q prime is smaller or equal to Q, the externality can be reduced. But there is one thing to be noticed. Once Q prime exceeds Q, it will bring more external costs instead. In all three of our solutions, the economic analysis indicates that they can all lead to a reduction in the equilibrium quantity of unsustainable fishing. In subsidies, we transfer the subsidies from unsustainable to sustainable fishing, changing the structure of supply without affecting the total cost. This solution can make changes to the short-term market. The second solution, taxation, might be a more long-term solution. However, there are still differences in unit tax and lump sum tax. With the same amount of effect, unit tax may cause less harm to the market as it will not force as many firms to leave as lump sum tax. As for our third solution based on the second best theory, under the model, both methods can not only change the equilibrium quantity, but also bring surplus to both consumers and suppliers. With the three solutions working together, we can expect the situation to be changed. Thank you.